Welcome back. So last class we discussed about vapor absorption refrigeration system and desirable properties of refrigerant absorbent for VR system. Then different types of VR system like simple aqua ammonia VR system, then actual VR system, lithium bromide water VR system, and three fluid system called as electrolux refrigerator. Right. Let us see some non-conventional refrigeration systems. Right. So it includes thermoelectric refrigeration, vortex tube, variable demonstration. Also, we need to study about steam jet refrigeration system. These are the contents I will cover in this class. Okay. First, we will see steam jet refrigeration system. Okay. Steam jet refrigeration system. What do you mean by steam jet refrigeration system? Is in this system, water is used as a refrigerant, water or steam, right? So if you use steam as an input for the system, so that if you are able to produce lower temperatures or cooling effect, it is called a steam jet refrigeration system. Once water is used as a refrigerant in the system, then we cannot go for below 0 degrees centigrade because that is one of the drawback. Because below 0 degrees centigrade, it becomes solid or ice, so ice cannot flow. So that always above 0 degrees centigrade applications, so we can recommend steam jet refrigeration system such as air conditioning. That is one of the major applications. Then drinking water, preparation of beverage products like soft drinks we are having. So while preparation of orange pulp, maja, so it can be used, right? Textile industries, if the temperature is more than 0 degrees centigrade, then we go for usage of steam jet refrigeration system. So this is the representation of steam jet refrigeration system. The important components are, this is called as flash chamber. This is called as flash chamber, and this is called as steam nozzle, which is connected to the boiler. This is called boiler where steam is generated, and this is called ejector section. So here there is no compressor, but we need to use ejector. The purpose is to increase the pressure to the condenser pressure. This is called condenser, and it is connected to pump. So always there is a loss of water, so that flash chamber level remains constant. For that we need to use addition of water. That is called makeup of water. And the cold water generated in the flash chamber will be taken by the pump and supplied to the air conditioning hall or air conditioning plant. After extraction of heat, the water will slightly heated. This warm water is again sent back to the flash chamber and is sprayed in the form of droplets. Right. So let us see. So when heat is given to the boiler, automatically water is converted to steam. So high pressure, high temperature steam is generated in the boiler. Then the flow rate of steam can be regulated by using this control valve. Then this high pressure, high temperature steam is expanded in the nozzle. Assume it is isentropic expansion. Assume it is isentropic expansion. So because of expansion through nozzle, the pressure energy converted into kinetic energy. Pressure energy converted into kinetic energy. So high kinetic energy of steam is passing here. Because of pressure energy converted into kinetic energy in this region, see the cursor movement in this region, very low pressure is generated. Very low pressure is created. That is the main principle involved in gas steam jet refrigeration system. So generally at room temperature or at atmospheric pressure, water boils at 100 degrees centigrade. If you are able to reduce the temperature of water surface to a value of 0.01 bar, then the boiling point is around 7 degrees centigrade. If you further reduce, it may be 5 degrees centigrade. So operating any system at low pressure so that water boils at very low temperature. Water evaporates at low temperature, and because of evaporation, we are getting cool water. So that cool water can be used for cooling of air. Later, it is used in air conditioning applications. So heavy vacuum is created in the flash chamber by expanding high pressure steam in the nozzle. So that very low pressure is created. Since it is open to flash chamber, whatever the pressure is exerted in the exit of the nozzle, same pressure is exerted over the surface of the water in the flash chamber. Because of very low pressure, so water starts evaporating. right? Here it is operating at very, very low pressure, maybe 0.001 bar, where water directly boils, evaporates at 7 degrees centigrade. So then automatically, because of high movement of steam, it will entrain, it will extract the water vapor in the flash chamber, so that steam along with the water vapor is passing to the condenser through ejector. So because ejector is a reduced class section, so that it will be compressed. It will be compressed so that the pressure of the mixture of the steam along with the water vapor will be raised. Then this increased pressure of steam and water vapor passing to the condenser, condenser, where coolant is circulated so that it becomes condensate. Then by using pump, it is supplied to the steam boiler again, right? From the pump, we need to supply the condensate to the boiler again. Meanwhile, because of evaporation of water at reduced pressure, the temperature of water in the flash chamber may reduce to 5 to 7 degrees centigrade. This is called chilled water. This is called as chilled water. This chilled water is taken by using pump and circulated in the air conditioned space or any cooling applications. Then after circulation, the water will be slightly heated. Again, the warm water is sprayed in the flash chamber to maintain same level. This is the way the steam jet refrigeration system will work. So these things already addressed. So working operation, I already mentioned. So whenever any water is evaporating, it depends on pressure. So if we are able to reduce the pressure of the surface of water, we can boil water at very low temperature. So if the pressure on the surface of the water is around 0.001 bar, the temperature of boiling point of water or evaporation of water takes place at 6 degrees centigrade. So 6 degrees centigrade water is very chilled water that can be used for cooling applications. So advantage, since water is taken as a refrigerant, so it is easily available, free of cost, non-toxic, non-flammable, non-corrosive, very less maintenance. Weight of the system per ton of will be less, no moving parts. So these are all important advantages. Drawbacks is, as we use the water as a refrigerant, we cannot go for below 0 degrees centigrade applications. Mostly it is used for air conditioning applications, mostly. And heat, about twice as much heat must be removed in the condenser steam jet per ton of refrigeration when compared to VCL system. So major drawback is below 0 degrees centigrade you cannot recommend to use. So that is one refrigeration system. Mostly it is used for air conditioning and drinking of cooling water. Then it is used in textile industries. It is also used in beverage products, etc. Then another one is called thermoelectric refrigeration, right? Another non-conventional refrigeration method is thermoelectric refrigeration. It mainly works on Peltier effect. Before moving to the Peltier effect, let us see there are some terminology called as Seebeck effect, Peltier effect, and Thomson effect. So among these, Peltier effect module is used to produce cooling, produce refrigeration, whereas Seebeck effect generally produce thermoelectric power generation, right? So these are the three. Thermoelectricity is based on upon three basic principles: Seebeck effect, Peltier effect, and Thomson effect. What do you mean by Seebeck effect? When two dissimilar materials forming two junctions, it is found that electromotive force EMF is generated. Electromotive force is generated. The amount of electromotive force generated mainly depends on temperature difference. Higher the temperature difference, more will be the voltage generation. So Seebeck effect mainly used for thermoelectric power generation. Most of the thermocouples works on Seebeck effect. So thermocouples mainly works on Seebeck effect. Then coming to the Peltier effect. When two dissimilar materials forming two junctions, when external current is circulated, it is found that heat flow from low temperature body to high temperature body. So it is the main principle involved in case of thermoelectric refrigeration, whereas Seebeck effect is used for thermoelectric power generation, right? So Thomson effect. When temperature gradient is maintained by the two bodies forming two junctions, it is found that heat will be absorbed or heat will be liberated. The heat will be liberated or absorbed mainly depends on the direction of current as well as the direction of temperature gradient. These are the two parameters. If you interchange, automatically the direction of heat absorption will be changed to heat dissipation. So this is the diagram which can explain the seebeck effect. So we are having two materials, material A and material B, forming two junctions, Tc cold temperature and Th hot temperature. So when these two materials are connected to a potentiometer, it is observed that voltage is generated. That is called a seebeck effect. So a series of seebeck effect is used in case of thermal power plants connected to chimney. We can generate enough amount of power. The amount of voltage generated directly proportional to delta T. So that ratio of potential difference by delta T is called as Seebeck coefficient. Peltier effect. A French watchmaker proposed Jean Peltier found this Peltier effect. So Peltier effect mainly used for thermal cooling applications. It states that when electric current flows across two dissimilar conductors, the junction of the conductors will either absorb heat or liberate heat. It depends on flow of current. As I mentioned earlier, when two dissimilar materials connected to two different temperature junctions, cold junction, hot junction, when external current is supplied, automatically heat flow from cold junction to hot junction. So it is used for year-round air conditioning applications, air suits. So for cooling applications used one end, where heating applications used in other end. So that is Peltier. So here the amount of current supplied is equal to amount of heat transfer. So higher the current supplied, more will be the heat transfer. So the proportional limit can be eliminated by using providing constant called as pi AB, where pi AB is called Peltier coefficient. As I mentioned, the heat energy liberated or observed in mainly depends on temperature gradient. So Thomson effect governs the cooling heating materials carrying current subject to temperature gradient. Then another one is called vortex tube. So vortex tube refrigeration in which there is no refrigerant required. That is advantage, right? So this is called as representation of vortex tube refrigeration, where atmospheric air is taken and it is compressed by using compressor. Then it is expanded through a spherical or conical valve so that vorticity is generated. Vorticity means curvilinear motion of air. Because of the air, compressed air is expanded in the nozzle, which is made in the form of conical shape. The two streams after expansion will be emerged. One is called as high dense air and low dense air. Hot air is called as low dense air, where high dense air is cold air, and these are emerged in two layers. And we are using the control valve so that it can regulate the flow rate of fluid. So the cold fluid moving in one direction where hot fluid is moving in other direction. So both can be collected, and based on the application, it is used for cooling application as well as it is used for heating application. Right. So vorticity means curvilinear motion of fluid. So curvilinear motion of air can be obtained by using conical nozzle provided at the center of the pipe. So even though we provide this design, so it cannot produce large capacity of air as per the requirement. Advantages: it uses air as a refrigerant, no leakage problem. There are no moving parts, light in weight. So main drawback is low COP. Right? Applications are also mentioned. So it is most commonly used for body cooling of workers in mines. It can be flexible. And last one is called adiabatic demagnetized refrigeration. If you want to produce very, very low temperatures, we go for adiabatic demagnetization system. Adiabatic demagnetization system. So magnetic refrigeration is a cooling technology based on magnetocaloric effect. It is mainly used to produce very, very low temperatures, maybe more, less than minus 180 degrees centigrade or minus 270 degrees centigrade, we can go for achieve, right? So here the magnets are used between the poles, and the sample is then cooled at very low temperature. I will show you. So here paramagnetic substances are used which are weakly attracted by the magnets. So by using this adiabatic demagnetic system, we can achieve the temperature below 0.6 Kelvin. That is very, very low temperature. See here, adiabatic demagnetization. At the center, we are having a chamber. It is generally filled with the helium gas, and a sample of paramagnetic salt is suspended by using nylon thread, right? And it is placed in the liquid nitrogen chambers. And we are providing radiation shield also, right? Radiation shield also. And the entire system is placed in the dever flask, and we are providing measuring coils also, and these are called as nylon threads. And the entire dever flask is placed in the magnetic field, so heavy magnets are provided either side. So this contains liquid nitrogen, and this is called as liquid helium. And in the chamber we will fill the liquid helium gas, and this is called as the paramagnetic salt material. Whenever the magnet switch is on, paramagnetic field is turned on, so maintained for about 1 hour. So to allow heat of magnetization to be conducted to the helium bath, this is called as liquid helium by the gaseous helium in the small chamber, thereby maintaining salt at its original temperature, right? So when thermal equilibrium is achieved, thermal equilibrium means the temperature of the liquid helium equal temperature of the liquid helium gas. So that sample also same temperature. That is called same. When both are well at same temperature, it is called thermal equilibrium. And then the gaseous helium will be pumped. So see here, the gaseous helium will be removed to thermally isolate the paramagnetic salt. When gaseous helium is removed, then automatically paramagnetic salt is isolated. Later on, the magnetic field is removed and temperature of salt drops to a very, very low value. So that very low temperature like 0.0014 Kelvin have been attained by this method. So mostly it is used in cryogenic systems. Advantages are no compressor use, no refrigerant gas, low pressure operation, low running cost, etc. But the main drawback with respect to the system is initial investment is very high when compared to conventional. Production of electron component magnetic fields. Permanent magnets have limited field strength. Electromagnet superconducting magnets are expensive. So cost wise, it is very, very high. Even though we are reaching very, very low temperature, but it is not economical. It is very costly. So research, a lot of research going on this adiabatic demagnetization, so that we need to use such suitable materials to reduce the cost and provide very high temperature. So these are the applications: cryogenic, magnetic into domestic refrigerator, refrigeration, medicines, plug-in display cabinet. All these are applications. Okay, thank you.